Hi, I'm Dave Burley. I'm an instructor here at the Physics Department of the University of Maryland, and I have the dumbbell demonstration, and what we're looking for is something that we call the center of mass. So my question is, I've got this object, two brass weights that are on either end. They're fixed to a certain distance apart by a brass rod, and I'm interested in where would I have to place this dumbbell onto this edge so that I could balance it, so that I wouldn't have it tip over. Should I place it right in the middle, closer to the lighter end, or closer to the heavier end? All right, so if we try to put it over here at the one end, I'm not even going to let go. It's just going to make a big loud bang as this end hits. Let's try at the center. And once I let go here, I still have that same problem. So let's try closer to the heavier end. And there we go. Now, the spot that we're going to look at goes by two names. You'll often hear folks call it a center of gravity or center of mass. Now, when we talk about it in terms of center of mass, we're taking that approximation that many of us physicists do when we first start talking about motion. We tend to like to not worry about what the shape of an object is. We like to think of everything as just a dot with mass. So when we talk about in the very beginnings of introductory physics, we start looking at houses and planets and people, and small furry animals is just that, just dots with mass, and worry about what happens when forces are applied to them. But of course, we know that once we make our models a little more sophisticated, we have to start worrying about how the mass is distributed. We also have to start worrying about where the forces are actually being applied on the object. And that's where knowing something about the center of mass can be very important. The center of mass is that Newtonian approximation that we've always made. And for simple objects like spheres or planets or most objects that are kind of evenly distributed, you could pretty much say the center of mass is smack dab at the center, but at that geometric center of the object. So it's a real easy approximation to make. But once you start looking at where masses are distributed in a more realistic circumstance, it's kind of saying that the center of mass is really an average of where all the masses and how far away they are from some particular point, and they kind of balance out. And finding the center of mass or the center of gravity, which is kind of saying, well, let's talk about the weight force and where that force is being applied, finding that can often be as simple as just trying to find a point where you can get everything to balance. Now, I mentioned the term torque a little while ago. If we imagine that each of these masses has their own weight associated with them, and we know that weight is a force that is always directed towards the center of the planet, so this object, because it has more mass, generates a greater amount of force, a greater weight force. Since my objects aren't evenly distributed, I need to find a way to talk about where I can keep them from twisting, where their torques or their twisting forces can balance out. Now, torque is a product of force, which is our weight that we have here, and distance away from a pivot or a fulcrum. And if I put my fulcrum, my place where I'm pivoting, at about the center of mass, I can say that the torques are balanced. So the product of force and the distance away from that axis is the same on both sides. And in doing that, I can get myself some balance.